The midpoint and distance formulas. Now, a lot of people from Algebra 1 remember that there is a distance formula, but they kind of forgot what it is. And the midpoint formula is usually 50-50 as to whether people remember that that even exists or not. They're like, I've never heard that before. So this is going to be a little bit of a review, but more of a crash course, meaning that if you didn't get it the first time, you might have to work a little bit harder. I'm going to explain it, but understand that there's not like a million examples back from Algebra 1. So let's take a look. All right. So the midpoint of a segment. Notice that we're talking about the midpoint of a segment. When we're talking about midpoint, it should feel like we're talking about the middle. It is the point that divides the segment into two congruent segments. I'm going to draw a little picture here. I'm going to draw a segment, but not with a... I'm going to draw... Actually, I'm not going to use black. Okay, so I'm going to draw a segment. I think we would all agree that that's a segment. And if I put a midpoint in here, and I'm just going to call that M, just so we remember that that's the midpoint, it should be understood that the midpoint of a segment divides the segment into two congruent segments. So watch what I'm going to do. Bam, bam. I made those marks because if that's the middle, then it must be true that the left side and the right side of that point are exactly equal. So if I told you that this whole line from A to B was 30 units long, then how much is each of those smaller pieces? 15. They have to be. They're the same length, so it's half of 30. And this next term, a bisector, is going to be a word that we use a lot. A bisector of a segment, so it's going to be, this is going to happen to a segment, can be a point, it can be a ray, it can be a line, it can be a line segment, it can be a plane that intersects the segment at its midpoint. I'm going to scroll up a little bit here, and I'll show you what I mean. I'm going to put a line right here, A, B. And then I'm going to put some weird line right here and call it C, D. Now let's say that for a moment I give you a piece of information, and I'm going to tell you, and I'm just going to say, here's a piece of information that you need to know, that CD is a bisector of segment AB. It means that it is bisecting AB. It is chopping it in half. That one that's diagonal there going downwards is chopping the other one perfectly in half, meaning this. To the left of that dot and to the right of the dot, they are perfectly congruent. A bisector, imagine, is just like something coming through and slicing it perfectly in half. So DC is the bisector. It is the one that is doing the bisecting. It is doing the chopping of AB. So we say it is the bisector. DC is the bisector of AB. It chops it and goes right through that midpoint. It goes right through the middle of that line. It's very useful information. It doesn't seem like it at first, but you go, if that's the bisector, now I know that the left side and the right side of this are congruent to each other. They're the exact same size. All right. So we got a skateboard here. Whether you believe it or not, I was like a skateboarding fool in high school. I was a dork, and I like a different kind of dork that I just loved skateboarding every single day. That was the thing I did. So what we're looking there is called a deck. Like for those of you that don't skate, this is that wood part of the skateboard. You just can't see the wheels of it. So that's what we're talking about here. It happens to be a very unusual pattern, but that's okay. I'm not judging. It says in the skateboard design, VW. I'm going to circle this in red so you know exactly what I'm talking about. So here's VW. That's this line right here from V to W. It bisects. So it's doing the chopping. This is the thing that chops something else in half. It bisects XY. So here's XY. It chops it in half right at point T, that point right there, meaning the green line has been chopped in half. This side is now exactly equal to that side, whatever they may be. And additionally, they tell me that XT, the distance from X to T, that's what XT means, the distance from X to T is 39.9 centimeters. That distance is 39.9 centimeters. And they want me to find XY. Now, the piece of information they told me is that green line has been bisected. It has been cut exactly in two. So talk to me about strategies using that information. Yes, ma'am?
You would multiply 39.9 times 2 to find the value of W.
Good. She's saying that there are two of these pieces that are exactly the same. So you could either add 39.9 plus 39.9 or just multiply by 2. So 39.9 times 2. That's what I got to, 79.8 centimeters. Notice I put the units on there. Very important. If they said centimeters, it must be important. I got to use centimeters. So we found xy, which is the total distance across, based on that one little line. But we did have to know this wouldn't have worked unless that was a bisector, because that's the only thing that told us that the other side had to be exactly the same. Like, for example, right now, if I say right now, I don't know, let's say I make up a number and I say I am 15 feet from the door, that does not mean I'm 15 feet away from the window unless I tell you I'm in the middle of the room. If I tell you I'm in the middle of the room, then that's okay. But if I go, I'm 15 feet from the door, how far away from I am the window? Is that all the information you're giving me? Because I don't know, then I gotta go measure how far you are from the window. But if I say, and I'm in the middle of the room, then you go, okay, well then it must be the same distance there. And that's what that bisector part gives us. You are in the middle at point T. But really what people get confused by, VW is the line that bisects the other one. The red line chops the green line in half. So that's what that means, like the actual grammar of it. All right, point M is the midpoint of VW. So here is our middle of the line. What does that tell me about these two things right here? Yes, ma'am?
They're congruent.
They're congruent, they're equal. These two things are equal to each other. Find the length of VM. So this part right here. Even if you're not sure, let's talk strategy. Let's just throw some stuff out there. What could we do? Okay. Perfect. Let me just catch up to you. Now I'm going to move the 3x to the left because I like all my x's positive. So whatever is the smaller x, I'm going to move it over there. So minus 3x, and I get x minus 1 is equal to 3. Now I'm going to add 1 to both sides to get rid of that. And I get x is equal to 4. Okay, great. X is equal to 4, but how does that help me when I'm trying to find out the length of VM?
You're going to plug into X.
Okay. Where? Where do I plug it in?
Where it says X.
Well, I have x here. I have x here.
Yes. Both of them?
Both of them?
You can plug it into one because if they're congruent.
Oh, yeah.
So the thing is that I could plug it in. Now, it's asking for VM, which is over here. So your instinct is probably just like, why don't I do it there? You're right. But the reason what people are saying is you could plug it into either of them because they're equal to each other. So no matter what, it's going to end up as the same number. But I'm going to stick with the one on the left because that's VM. You wouldn't be wrong if you did the other side. I'm just going to do the one on the left because that's what they asked for. Here we go. We've got 4x minus 1. And I know that x is equal to 4. So we get 16 minus 1. Or 15. What if I asked you how long VW is?
It would be the same.
Oh,
You know that you're 30, you have to add.
Yeah, we'd have two of those. We'd have two 15s, so we'd have 30. So both sides are 15. I don't have to plug it back in to know that, but I could plug it in to check. If I was worried that I did some math wrong in there, I'm going to plug it in the other side just to check. Like I go, man, I did not have my Frappuccino this morning. I'm going to go 3 times 4 plus 3, and this better be 15 or I messed up. So 12 plus 3, that's definitely 15. I feel good about that. One side's 15, the other side's 15. The whole thing is 30. Yes, ma'am?
So the midpoint and the bisection are basically the same thing.
So a midpoint is the middle of a line. A bisector is a point. So I could say point M is the bisector of line VW. It is the thing that goes right at the middle. So a midpoint is just the point that is the middle. But a line can be a bisector too. I could make that line go up and down. That could be a bisector. It's slicing it. So the line isn't the middle, it's the line that goes through the middle. It's that line is indicating to me, just follow that line down and you'll find the midpoint. So it's kind of an indicator that like, hey, bro, you're going right through the middle there. Yes, ma'am?
So just to be clear, the bisector is like, why you have a bisector, that's what causes it.
So unless you're a lunatic, when you cut a cake, right, you go right down the middle, right?
Mm-hmm.
I don't call the knife the middle. I call the knife the bisector, right? It is the thing that is cutting it down the middle. So think about that. Like the knife that cuts the cake is the bisector. It is the thing that is going through the middle. But unless you're like some weird person that like cuts a corner out of a cake or something like that, don't ever come to my house then because we're not friends and I don't like you already because that's weird. You got to cut down the middle, right? Like because you want to get all those like perfect like slices of cake or pie or whatever. So we all shoot for the middle down there. So the knife is like the bisector coming down and hitting the midpoint, in this case of a pie or a circle.
And it only hits the middle, right?
Right, a bisector always hits the middle, always. And when you hear the word bisector, that's a guarantee. Now, you may not, when you're slicing a cake, you might try and you'd be like, ugh, but whatever. But the idea of a bisector will always go through the midpoint. All right, so here is the midpoint formula. Now, understand, I will not be giving you a formula sheet. So this is important that you understand this. I'm going to give you something to help you memorize this in a minute. But just understand that if you are given two coordinates like 0, 4, and 5, 7, I could ask you to find the middle of those 2 points. Meaning if you were to graph them, they would make a line between those 2 points. And I said find the middle. Well, that would be really easy if that line was flat or if that line was vertical. But what would be hard is if that line is going diagonally. And that's what the midpoint formula covers. If anything, and give me any 2 points in the world, I can tell you where the middle is as long as I use this formula. It says take x sub 1 plus x sub 2 and divide by 2. Now, what that sub 1 and sub 2 mean, if you've never seen that before, that they're down below, it just means that you're going to have two different x values. Notice there is an x value here and an x value there. I don't care which one you call 1 and which one you call 2. That doesn't matter. It would be like if you and I were about to go somewhere and have lunch together and we both ordered a slice of pizza and they dropped 2 pieces of pizza on the table and said, here you go, folks, eat up. There are 2 pieces of pizza. I don't care which is 1 and which one is 2. There are 2 pieces of pizza. You take one, I'll take the other. It doesn't matter how we label them because when we add numbers, the order doesn't matter in how we, like 0 plus 5, 5 plus 0, it doesn't matter. It's the same. Same with the y's. Y sub 1, y sub 2. It means there are 2 different y values that we're talking about here. We're going to add them together and then divide by 2. Now, what you're looking at here, hopefully maybe this is like, wait, this seems like there's something to it. If I wanted to know the average of something, we're talking about an average is like the middle of 2 things. So like if I have 2 things, like the average of our 2 ages, if I took my age and I took your age and we wanted to average them, we would add them together and divide by 2. That would be the average of our ages. Just like with these, we're going to add up 2 points, add them together, divide by 2, and that will give us the coordinates. Now notice there's a comma there and there's brackets around it because our answer is going to be a set of coordinates where we have the x middle value and the y middle value. So I put that m there to show you that's the midpoint. Here's the middle x value and the middle y value. If you were to graph this, it would be directly in the middle of that line. Take the x's together, take the y's together, add them up. When you add up the x's and divide by 2, you'll get the x middle coordinate. When you add the y's together and divide by 2, you'll get the y middle coordinate. Yes, ma'am?
This whole formula would be for a graph, right?
Yeah, so like, but you don't even have to graph it. What I'm saying is that I could just ask you for the middle of those 2 things. We don't even have to graph it. I can just tell you where the middle is. Because a lot of times people want to graph it and start counting over and trying to figure it out. You don't even need a graph for it. We could figure it out. For example, in those 2 numbers I've got up there, we'll agree that these are both our x's, right? So I'm going to call this x1 and this x2 just so we can all follow along. So 0 plus 5 divided by 2. That is 5 divided by 2, which is 2.5. Now I'm going to do the x's. 4 plus, the y's. 4 plus 7 divided by 2. 4 plus 7 is 11. 11 divided by 2, so we've got 11 divided by 2, is 5.5. If you want to know where's the point that is the middle of those 2 points, it's at 2.5, 5.5. That's the middle of those 2 points. Those 2 points that I originally gave you will form a line. Where's the middle of that line? Right there. It's a line segment, I should say. It's not a line. In between those 2 points, where's the middle? At 2.5, 5.5. Yep, there is our middle coordinate for the x and our middle coordinate for the y. If we wanted to graph it, we would see it's exactly in the middle of those two. All right, so we're actually going to do them right now. And the second one looks really hard, and it's the one that nails everybody on the actual quiz. I got to move pretty quick here. If for some reason we don't finish, I might extend it into tomorrow because actually there are 3 different geometry honors teachers, and we are ahead of all of them. So we are doing much better than everyone else. So if we need to extend it and slow it down a little bit and go to tomorrow, great. But I want to do some review tomorrow too because we're quizzing next week. This is our last lesson that we're going to have for our quiz next week. So I want to prepare you guys for that. Yep.
Quiz will be on
These 3 lessons. So it says find the coordinates of the midpoint, which means I'm going to use the midpoint formula. I don't know about you, but I have found one of the best ways that I remember things is if I just keep writing them over and over again. So here's my midpoint formula. x1 plus x2 divided by 2. That's my x coordinate. And then y1 plus y2 divided by 2. There's my y coordinate. Now, again, I don't care which one of these things you call x1 and which one you call 2. So look, I have an x and a y on both of those. If you want to call the one on the left the second one, fine, that's okay. I just like to read left to right. Here's the first x and the first y, the second x and the second y. There's 2 different sets of them, right? That's what I'm going to look at. So I get 0 plus 6 divided by 2, and I get 4 plus negative 2 divided by 2. 0 plus 6 is 6 divided by 2. 4 plus negative 2 is 2 divided by 2. Simplify that one step further, and we get 3, 1. The middle of those 2 points, the midpoint of those 2 points is 3, 1. Add up the x's, divide by 2. Add up the y's, divide by 2. And you're going to see in a second, even when it gets ugly, even when things are like, wait, what? Whoa, what? I don't even know what's going on here. You're still going to do the same thing. So even though this looks ugly here on the second one, we're going to do the exact same thing, and you're going to see it works out just fine, even though you're going to be uncomfortable with the answer for just a moment. All right, here is an x, here is an x. Here's a y, here's a y. Those are just sets of coordinates. Now, granted, they don't make much sense to me right now, but that's okay. Here's the first set, here's the second set. x1, which is b plus 2. Yep.
B plus 2 is x1.
That's the first coordinate.
So you're asking me,
Yep. Plus x2, which is 3b, and I'm going to divide that by 2. Now with the y's, we're going to do 0 plus 6 divided by 2. God bless the y's because they're nice and easy. So let's get those y's done real quick. That's 6 divided by 2. That's going to end up being 3. That's nice and easy to do. Now up here, I'm going to combine like terms. B and 3b. What's b plus 3b? 4b. So on the top we have 4b plus 2 divided by 2. Is everybody okay with how I got that? If not, stop me now because I don't mind. I won't judge you. Yep.
There's 2. Why do you have 2 sets of parentheses? Isn't it just 1? 3 is whatever we solve for that.
I'm sorry. When you said 2 sets of parentheses, what do you mean? So these are the parentheses that I'm using. These parentheses right here around the formula are these right here. The reason I put one around b plus 2 because I wanted everyone to be able to see that that's the first x coordinate. So right here is my first x coordinate. And then that is already being separated from the second x coordinate. First x coordinate plus the second x coordinate.
I was talking about under. No,
Down here?
that's 2. But you're going to end up putting that next to 3, right?
I'm sorry, I don't understand.
No, it's okay.
Okay.
Can you re-explain how you got 4b plus 2?
Right, so I have b plus 2 plus 3b. I'm just combining like terms. 1b plus 3b is 4b's. So when you don't see anything out in front of there, we just know that that's 1b. 1b plus 3b is 4b. 4b plus 2. Now this can still be simplified a little because what this means is that when we have a fraction like this, this is being divided by 2, and this is being divided by 2. So let's look at the left side there. What is 4b divided by 2?
2b.
That's 2b. So the first part is 2b. And the second part is 2 divided by 2. 2 divided by 2 is 1. So we get 2b plus 1, comma 3. Now, if you're like, bro, how do I graph that? Bro, I don't know. I don't know how to graph that. I don't know where that is on a graph. I'd have to see what the graph looks like, and then maybe, but it didn't ask that. It just asked me for the coordinates, in which case I've done that. So I'm not worried about what it looks like. Right now, I'm worried about, there's your answer. There's the coordinates. I couldn't find that on a map or anything like that, but that's the coordinates of the midpoint.
Even though it has a variable.
Uh-huh. So the idea is this, is somebody said, if b equals 2, what would the midpoint be? Well, then I need to plug in 2, and I would find out. If b equals 4, what would the midpoint be? So, like, you could actually plug it in at that point if you wanted to. Yes, ma'am?
Is it possible for you to not be able to find a coordinate?
I mean, you're going to have something at the end. There may be nothing that combines, like maybe nothing combines and you just end up with like a big looking equation, but you're always going to be able to add two things together. I mean, I'm going to do something ridiculous here and it's going to seem funny, but like even if I go cat plus dog divided by 2, well then the midpoint coordinate is cat plus dog divided by 2, right? I mean, I don't know how to add those two things together, but if I take cat divided by 2 plus dog divided by 2, then there you go. That's the x coordinate. Yep.
If you can't divide it by 2, you just leave it like that?
Yeah, so like if it was like 5, I mean, in this case, in most cases, I'll tell you whether I want it as a decimal or if I want it as, like, everything can be divided by 2. You just may end up with a fraction or a decimal. Do not worry about the homework tonight. I will finish it up tomorrow. You get a free night tonight.